How you going, guys? Curtis from Cutting Edge Engineering. So today we're going to be continuing on with our tailstock chuck build for our Megabore Lathe. So if you missed part 1, there'll be a link in the description below. And as you can see, our new 4-jaw chuck has arrived, so we're going to get it opened up and have a look at it.
Is that going to be the same as for that one?
Yes.
Oh, perfect. There we go.
So straight away you can see the quality of this chuck is 100% better than that sharp chuck, and I'm very happy that I decided to buy this one.
Oh, lovely.
And the back of this 4-jaw is exactly what I had envisioned when we designed the tailstock chuck, and all we're going to need to do is make a modification by machining down this face so the 4-jaw is the same profile as the 3-jaw. That way we can use the same backing plate for both chucks. Now we've got all that worked out, we can continue on with machining, so we're going to get our part set up in the lathe. Now we've got that set up, the first thing we're going to do is turn down the outside diameter to 400 mil. Because that is a plasma cut edge, it is a little bit hardened, so I need to get through that hardened material, and once we do that, we're going to change over to a fresh edge on our insert.
fresh edge.
Now we've got the OD machine to size, we are going to face it, but you will notice there is quite a bit of distortion there from the welding process. The plate does have a curve in it now, and that's why we went with 25mm plates, so we have enough material to remove and still keep the strength. So I've taken our facing cut, but I'm not really happy with that surface finish because of the distortion in that plate. As the insert was getting closer to the center of the plate, the depth of cut increased, which then pushed the tool and the carriage back a little bit. So I'm going to take another cut just to clean that up. So much happier with that surface finish now, but the next thing I need to do is machine a shoulder onto the plate, and that is to match the recess on the back of the 3-jaw chuck. The shoulder needs to be 340mm in diameter, and I'm going to machine it about 5mm deep. Now we've got that machined to size, we're just going to test fit the 3-jaw. So that fits perfectly, but I'm just going to hit some of these edges with some emery tape just to remove all the burrs. That's all the machining done for the moment on this side. What we need to do next is flip it around and start machining the other side. Now we're going to finish machine the OD, and we're going to machine that down to 250mm because that is the same diameter as the tailstock. Now we've got the OD turned to size, we're going to machine this face. And just to show you how much that plate has warped and distorted from the welding process, I've gone in and touched off right beside the weld and zeroed out the digital readout. Then I will come all the way to the outside and touch off, and we'll see how much it's moved. So that actually distorted 1.5mm. Now I'm going to change out to a button tool with a 16mm insert, and I'm just going to machine down that weld and put a nice radius in that corner, and that's just to make it look good. I just want to add a little chamfer to this back edge, and to do that I'll use an S&MG neutral. Now we've got that done, we're going to get the tailstock chuck out of the way so we can reset up the steady rest and finish off the ID. And I wanted to do this process last because it is the most critical, and I didn't want to run the risk of any of the external machining releasing any stress into the bore and pulling the ID out of shape. What you got? Chicken. Huh? And this is critical because this is where the ball bearings come into it. Not only are they going to help support the tailstock chuck onto the quill of the tailstock, but they'll also allow it to rotate. And we're going to use a bore gauge to do the measuring of the ID, so we need to set the bore gauge to the outside diameter of the bearing.
Yeah, it's perfect.
So I've got that machine to within 0.4 of a mil of its finished size. Because we are taking finishing cuts, I have let it cool down, and I've changed out from our D&MG roughing insert to a finishing insert. So we know the outside diameter of the bearing is 200 mil, and that's what we've set our bore gauge to, but we do want to have a little bit of crush on the bearings. So we're going to machine this to 199.97, which is going to give us our 0.03 crush on the bearing. So we have 0.29 of a mil to remove, and I'm going to take that in 2 cuts. So we are nearly there, but it is currently still a little bit tight for the bearings, so I'm going to remove another 0.03 of a mil. Righto guys, so I'm happy with that. We've got that measuring spot on to our 0.03 crush that we need. Now we're going to get on to cutting the grooves for the snap rings that are going to be used to retain the bearings. And to cut the grooves, we're going to be using a 4mm grooving tool. So originally I only planned to use 2 bearings, one in the front and one in the back, but after having a think about it, because of how big the lathe is and the diameter of the quill, I decided to double stack the bearings instead, which will add extra support. So we know the depth from the face to the stop shoulder is 184mm, and the bearings are 20mm each, and we're going to be double stacking them, which gives us a total of 40. So we're going to touch off on the face and go in 144mm, and that will give us the location for our first groove. So we are going to get quite a lot of chatter and harmonic coming out of the bar because of how far it's sticking out. But this is the only tooling option I've got right now, so we're just going to deal with it. So with that one done, we're going to reset up the bar so we can cut our final grooves. And for the last groove, we're going to move back 44mm, which allows for our 40mm bearings and the grooving tool. Next thing I'm going to do is relief cut these two faces, and that's to allow easier installation of the bearings. I'm also going to chamfer the outside and the inside of this end. And the last thing we need to do on the lathe is drill a center hole down the inside in the back of the plate, and that will be for this to locate onto the live center when it is on the quill of the big lathe. But before I can drill the hole, I need to move the steady rest out of the way. Perfect. Righto guys, so that's all the lathe work completed on the body for our tailstock chuck. We still need to drill and tap the holes in the faceplate to mount the chucks, install the bearings and the snap rings, modify the 4-jaw chuck and get everything assembled and tested. But you just have to stay tuned for that video. Thanks for watching. Now we've got all that worked out, we're going to get back onto machining. We're going to get our parts set up in the lathe and start machining.
Good. Keep going.
Righto. Righto. So, oh fuck me.
There we go. Very nice.
Even smells nicer.
Yucky. Is that from the insert though?
Yeah, it's the insert's fucked. Because that is a plasma cut edge, it is a little, oh fuck me. Breathe. Because that is a plasma cut edge, it is a little, oh fuck me. And all we're going to need to do is make a modification. Oh, fuck, how do I say that? And all we're going to need to do is make a modification. Oh, fuck me, I did it again. I'm just going to add a little chamfer to this, but, oh, wait, what are we calling it? Next thing I'm going to do is I'm going to, wait, what'd you say? I'd like to start again, please.